once again. Today we are going to look at geometry, and we are going to look at geometry involving a parallelogram and also triangles. The equation was given here, we'll use it also to cover a rest of majority of other explanations that we are going to chip in. Now, it is said that if the shape ABCD is a parallelogram, we were asked to determine the value of angle A1, angle C1, angle E2, and angle E3. This being a parallelogram, the first thing we must take into consideration is to understand the properties of a parallelogram. The first thing we note is that a parallelogram has a pair of opposite sides equal and parallel. But in this case, we don't need that. So we go inside to find out other properties of a parallelogram. Interior opposite angles are equal in a parallelogram. So because of that, we have it that the whole of A will be equal to the whole of D. In a nutshell, A is equal to 80 degrees. But it was indicated that A1 is equal to A2. So in that then, A1 equals to A2 will be equal to 40 degrees because it was given. Please remember, another thing we must note here is that all reasons must be given. So here we cannot just write this without telling people why we are doing this. So we have to indicate by saying opposite angles of a parallelogram. And the second one is given. Opposite angles of a par shows that we have given the reason and we know why we are using the 80. So with that, we've gotten our A1. Let's go to getting our C2. If you look at this triangle CEA. In triangle CEA, we have AE being equal to AC. This indicates that triangle ACE is actually an isosceles triangle. If it is an isosceles triangle, another property is that the base angles of an isosceles triangle are also equal. So, in that way, we can write that A1 is equal to C1. And our reason will be base angles of isosceles triangle. In this case, because we have many triangles, we have to mention the triangle we are talking about. So, angle equal opposite equivalent shows that C1 is equal to A1. Now let's go to E2. For us to get E2, angle E2, we have as the third angle of triangle ACE. Remember, we've gotten our A with A1, we've gotten our C1, so E2 completes the third angle. So E2 will be 180 degrees minus A1, which is 40 degrees, minus C1, which is equivalent to A1, which is also 40 degrees. We can use sum of interior angles of triangle ACE as our reason. And in that then, our E1 is going to be 100 degrees. Now let's go to getting our E3. Our E3 is going to be, look at this. This is a revolution. A revolution angles around a point sums up to 360 degrees. It means that E1 plus E3 plus E2 will give us 360 degrees. So we have E3 being 360 minus E2, which we just figured out now, minus E1, which was given as 90 degrees. And then we can have our reason as revolution, or angles around a point. Therefore, our E3 in this case will be, angle E3 will be 360 minus 100 is 260, minus 90 is 170, sorry. So we have 260, and then we have 170 degrees as our E3. So our E3 is 170 degrees. Remember 90, 190 plus 170 makes 360 for the revolution. Now let's go to the second question. We were asked to calculate the value of x. There's no x in this side, there's no x on this side. But if we look at this, we see that inside here we have x. We have 3x plus 30. We have 2x minus 120 given. So with that, we can work towards getting the value of x using the properties that is associated with quadrilaterals. If you look at this, ECDD is a quadrilateral. And the sum of interior angle of every quadrilateral is, remember, sum of interior angle of every quadrilateral is 360. It is 360. Let's fill in what we already have. Now, this means that if we want to solve for x, we add up everything and they are supposed to sum up to 360. So we have 3x plus 30 plus E3, which is 170, plus 2x minus 120 plus 80. All of them will sum up to 360 degrees. And our reason will be angles in a quadrilateral. Sum of angles in a quadrilateral sums up to 360. Now let's collect items. 3x plus 2x is 5x. And I have 30 plus 170, that is 200. Minus 120, 200 minus 120 is 80. Plus 80, that is 160. So we will collect items, so we have 360, 160 going over minus 160. So we have 5x equals to 200. That means the value of x is actually 40 degrees. The value of x is 40 degrees. Now let's look quickly at the last question here. If we should determine if ED is perpendicular to DC. If ED is this line, is it perpendicular to DC? If this is EC. If EC is perpendicular to this. So we check using our x. If EC, so angle C, if they are perpendicular, then this angle will be at 90 degrees. This angle will be at 90 degrees. So the next one, which is question number C, we are just going to sub in the value of x to check if that angle will give us 90 degrees. To check if that angle will give us 90 degrees, so we have 3x plus 30 as that angle, so this is plus 30. So 3 times 40 is actually 120 plus 30, so that angle will be 150 degrees. If that angle is 150 degrees, authoritatively, we can say therefore, EC is not perpendicular to GC because our reason is because ECD is not equals to 90 degrees because it is only when they are 90 degrees that they will be perpendicular to each other. So this is how we have broken down this question. If you have questions, please, or you need more clarity, like I always said, post a comment and I will create a special video for you. For the meantime, keep on sharing my video, keep on encouraging your friends to subscribe. I'm here to help and support you and help you get rid of the phobia for mathematics. I will see you in the next video.